Simcenter Femap 2401 includes extended support for dynamic analysis of incompressible fluids. While previous versions of Femap included support for modeling the incompressible fluid implicitly as a virtual fluid mass, Femap 2401 allows users to model the incompressible fluid explicitly as a defined fluid mass with solid elements. The defined fluid mass allows users to model complicated fluid volume shapes and extended fluid volume types, such as volumes with sloshing free surfaces. We can use these capabilities to compute the effective elastic modes of the structure when the fluid is able to slosh. This video will demonstrate that capability. In this model, which represents a satellite structure, I've used plate elements to model the structure and solids to represent the fluid elements. The nodes defined in the meshes are separate. I've also defined a fluid region which specifies the details of the incompressible fluid surface. This model has two fluid regions, an upper region and a lower region. If I right-click on the fluid surface and select Edit, I can change the settings I have selected for the surface before analyzing the model. In this model, the fluid volume has a free surface, and the free surface is set to Allow sloshing. I've also selected the fluid element faces that comprise the free surface and have defined my acceleration due to gravity. I do not need to specify the wetted surfaces of my structure since the solver, Simcenter Nastran, will do that automatically. Now I will edit my analysis set, which I have already defined, by opening the Analysis Set Manager, expanding the Options tab for the correct analysis set, expanding the Incompressible Fluid Options tab, and double-clicking any of the settings. In this dialog, I can define my computational method, surface flatness tolerance, and various other options to configure the solution. The number of slosh modes is usually equal to the number of nodes on the sloshing surface. To get the elastic modes, I need to compute the number of expected slosh modes and the number of elastic modes of interest. If I just want to retain the lowest frequency modes and neglect the higher order slosh modes, I can use the slosh CMS parameter to perform component mode synthesis reduction on the degrees of freedom of the sloshing free surface. The number that I assign here is the number of degrees of freedom to retain for the sloshing free surface. In this case, I will select 20. I will click OK, and then I will click Analyze to analyze my model. After solving the model, we need to import the 2D plot-only mesh that covers the slosh surface in order to post-process the sloshing modes. In order to do this, I will use the command File, Import, Analysis Model. After clicking OK, navigate to and select the .dat file that was just created and double-click it to open it. You may have several .dat files that were just created. If so, select the one that says plotl in the name. Once the correct analysis model has been imported, the plot planar elements can be seen in the model. In order to better visualize the results, I will turn on my clipping plane using the View Style icon on the View toolbar. I can simply click the Clipping On option to activate my clipping plane. I can use the same toolbar icon to edit my clipping plane if I want to change the view that the clipping plane gets on my model. Once my clipping plane is set, I can view various sloshing modes by double-clicking on different output sets in the model info tree and clicking the Animate icon on the Post toolbar. To help me better visualize these displacements, I will turn on a contour plot of total translation. To do this, I will use the shortcut F5 to bring up the View Select dialog and click on Deformed and Contour Data. From there, I can set my contour output vectors to total translation, click OK, and then click Contour in the Contour Style section. Thank you for watching this video on dynamic analysis of incompressible fluids in Simcenter Femap version 2401.